Let's finish this up. We are going to start with lesson 19C. So here we go. Lesson 19, problem C. All right, so problem C is a geometry problem. So let's do this one. Got this line. I have to draw these, but you'll notice that I'm a little bit better when I draw online than when I draw on the board because I have some tools that can help me. Maybe it's not that much better. Okay, so we have something like that. Really, the right triangle should be bigger than the left, but that's just not how it worked out for me. So here we go. We have sides. We have a 5 and a 3 and a 4 and a y and an x and a 5, and we have to find x and y. They also give you these angles are equal. These are vertical angles, so they're always congruent. Congruent is just another way of saying equal, but it doesn't have a number associated with it. It's more of a picture. They lay on top of each other. Okay, so basically what they're saying here is if two of the angles are congruent to two of the angles of the other triangle, that means the third angle is congruent, and that means that the triangles are similar. If the triangles are similar, then their sides are proportional, and we can make proportions. So you need to line up the one with the 1 and the 3 goes with the other one with the 1 and the 3, the little slashes there. So we're trying to find the ones that match up that don't have a variable, and that would be this 3 is between 2 slashes and 3 slashes. The 5 is between 2 slashes and 3 slashes. So that's going to be our starting fraction. So we're going to use 3/5, and we went from left to right, and now we're going to go left to right. And the 5 matches up with the x. They're between the 1 and 3 slash, between the 1 and 3 slash. So it's going to be 5 and 3. Once we set up a proportion, and I shouldn't put 3, it should be 5 and x. So it's this 5 goes with this x. And now we cross multiply, so we get 3x equals 25, and we solve that, we get x equals 25 over 3. So that's the first one. Then we get y. We're going to start with the same 3 and 5. But this time we're going to use the other numbers, the 4 and the y. So it's going to be 4 over y. Cross multiply, we get 3y equals 20. And we divide by 3, and we get y equals 20 over 3. So there you go. That's how you do C. Cross that one off our list. So we have a few more for 19 and 20 than we did for 17 and 18. Okay, the next one we're going to do is I forgot to do B. So let's go back and hit B. B is a value problem. So we're on lesson 19B. This one says roses sold for 12 pence each and daffodils for 4 pence each. If Jim bought 35 flowers and spent 300 pence, how many daffodils did he buy? Okay, so the first equation is only going to talk about the number of flowers. It's not going to have how much they're worth. So we can just do number of daffodils plus the number of, what's the other one? Roses. I should do the other way around since it was mentioned first. Let's do that. Number of roses plus number of daffodils equals 35 flowers. Now we're going to do value. That's just if you were just to throw all the flowers on the table and count them, the roses and daffodils would be 35. Now let's talk about roses, the value. Roses are 12, so we're going to do 12 times the number of roses. The daffodils are 4, so 4 times the number of daffodils is going to equal a certain amount of money, and we're talking pences, whatever that is, so it's going to be 300. And then we can do a couple things. We could either divide everything by 4 to make it easier, or we can just solve this guy by multiplying through by, let's see how I did this here. Actually, I divided everything by 4. So let's just do that. So it's n sub r plus n sub d equals 35. If you divide everything by -4, it's going to work out nicely. So it's the same as multiplying, but we're dividing. So we're going to get -3 number of roses. We're dividing by -4, so it's going to be negative. So if I put this right here, we're dividing by -4. It's just another strategy. We could have multiplied the top one by -4. Just working on different strategies this year. So it's going to be negative number of daffodils equals -75. I mean, it is very negative. That's the only negative about this. So -2 number of roses is going to equal -40. And the number of roses equals 20. And then you go back and you get the number of daffodils would be 15 because 20 plus 15 equals 35. Okay, making our way out of the practice problems, we're going to venture into, someone asked for number 6, but that is an even problem, so I'm not going to do it. But we can do number 3. So number 3 says sulfur is mixed with other chemicals to make sulfuric acid. If it takes 16 tons of sulfuric to make 49 tons of 16 tons of sulfur to make 49 tons of sulfuric acid, how many tons of other constituents are needed to make 294 tons of acid? Okay, so we're going to set up a little ratio box. So this is lesson 19. Excuse me for 1 minute. I have to get a smaller pen and I have to just do something real quick here. I don't like when it's so fat that it feels like I'm writing with a marker. So hold on 1 sec and I am back. Okay, so this is lesson 19, number 3. So we're going to set ourselves up with a little ratio box. We're going to have our sulfur. So they want to know how many other things we're going to add to the sulfur. So I'm going to call that other. And then we always have our total when we're doing these boxes like this. Okay, it tells us that the sulfur was 16. We don't know the other, so I'm just going to put a little block there because we don't know the other. And the total, it tells us they want to make 49 tons of sulfuric acid. So how many tons of other constituents are needed to make 294 of acid? So because we have the sulfur and we have the total, we can subtract these two to get the others. So the other is going to end up being 33. Sometimes they give you this, like the sulfur and the other, and you have to figure out the total. And in this kind of problem, they give you the sulfur and the total, and they give you a hint there, sulfuric acid is the total. And now we have to find how many tons of other. So that's going to be our variable x. We're going to make ourselves a little proportion right in the problem because we don't need this. We only needed the sulfur to be able to determine what the other was. We're going to cross multiply here, and we're going to get 9,702 equals, if we cross the other way, we're going to get 49x, and if you divide both sides by 49, you're going to get x equals 198 tons. Make sure you put the units on there. Okay? All right, we got that one. Let's move on. Now we're going to do number 7. So 7 is one of those long division problems. So let's no it isn't. It's a multiplication problem. So lesson 19, number 7. So we have x cubed minus 2x squared. I'm going to do it the way I do it, minus 2x. I think the book does it this way too. We're going to multiply that by x squared minus 2. So I just put the bigger one on top, and I'm going to do it just like we would do a normal multiplication problem, 2 times this, 2 times this, 2 times this, 2 times this. So sometimes it works better if you start from left to right so that you can get your signs in there. So I'm going to do it that way this time. And that should be an x cubed up here. So let's just make sure I got everything copied right. So we're going to get negative 2x cubed plus 4x squared plus 4x minus 8. And then I'm going to do the same thing. I'm going to line them up in the right places. Now, when I take x squared times x cubed, it's going to give us x to the 5th power. So I'm going to actually go this way, just so I get everything lined up. So we get 4x squared. That's going to line up underneath the 4x squared. Then I'm going to get negative 2x cubed. I'm just going to put the plus there. Negative 2x cubed. Wow, they're ending up being the same thing. How about that? Then I'm going to get a negative 2x to the 4th. So we'll put that out there. And then we're going to get the x to the 5th. So I just did it. You can do it either way. You can multiply this way, or you can start this way. The reason I did this one this way is I wanted to make sure everything lined up, and I didn't have a place for the x to the 5th. I could have made a place. And then you just add your columns up. So you get x to the 5th minus 2x to the 4th minus 4x to the 3rd plus 8x squared plus 4x minus 8. And I think I got that one right. Okay. And that is number 7. Okay, the next one, we went from 7, we're going to 11 now. So lesson 19, number 11. Okay, another one of these. R sub m, t sub m equals r sub r, t sub r. That's your mother equation. Here's the little babies. R sub m equals 8, r sub r equals 2, t sub r equals 5 minus t sub m. So we're going to substitute it in. This variable is the one we're going to leave in. You have to have somebody that you leave in there. So I'm going to start substituting. R sub m is 8. T sub m, remember that's the one we're leaving in, so we're not going to substitute in for that one. R sub r is 2. T sub r is, okay, when you can't read your writing, let me look again, 5 minus t sub m. So you substitute it in, you just distribute through, so you're going to get 10 minus 2 t sub m, and we're going to add 2 t sub m to 8 t sub m, and we get 10 t sub m equals 10, and you divide by 10 and you get t sub m equals 1, and t sub r, you take this up there, and it's going to be 5 minus 1, which is going to be 4. Ta-da! Okay, so we have those two answers for you. Okay, number 11, and the last one is number 21. Okay, that one looks like a blast. That's a circle with some stuff going on in it. So let me give that one a whirl. I have to draw this one, so hold on. This should be interesting. So we have a circle. I'm really good at drawing circles on this thing. And we have some inscribed arcs in a central angle here. So let's put our center in just to get that straight. And let's just draw our central angle first. So angle A is actually our central angle. It's a central angle because it comes out of this center. That's tricky, isn't it? Okay, and then we also have inscribed angle, which is going to continue this one down here. And let's see if I can get that somewhat straight. And then we have one coming up here. So one is a central angle, and the other one is an inscribed angle. The central angle is the same as the intercepted arc. So from here to here is 50 degrees. That means angle A, what are we supposed to find? A, B, and C. That means A, right here, angle A, is going to be 50 degrees. Okay, they have the degree there, so you don't need to write your degree in the answer because if you substitute it in, it would be there. Okay, now we can get angle D, which is down here. D is an inscribed angle, which means it's half of the intercepted arc. So D, it's actually not there, it's actually inside of here. D is going to equal half of that, which is 25. Now they want us to get B, which is right here, and C. Well, we can get B pretty easily because if A is 50, these are supplementary angles and they form a linear pair because they're two angles that lie on the same line. So B has to be 180 minus 50. So B is 180 minus 50, so it's going to be 30. And then finally we can get C. We can get C because we know B and D, and we're going to subtract those from 180 because the measures of a triangle, B plus C plus D, has to equal 180. So I'm going to take 180 and I'm going to subtract 55 from it, and we get 120. Whoa, that didn't quite work. Doesn't look like 125, or does it? D is 25, and B, it's 130. I don't know what happened to that number. Okay, so 180 minus 155 is 25. So the lesson to be learned there is if it doesn't look like it's right, try it again. Moving on to our last lesson. So we're going to lesson 20. We only have 5 problems. I think I can manage this. So here we go. Lesson 20. I hope somebody's watching this. Okay, 20, number 2. So we are doing the evens. Lesson 20, number 2. Let's do B first because that's our practice problem. We'll do that first. Okay, so B is, oh, I love these problems. So 3 root 2 times 3 root 2 minus root 8. You can call it square root or you can call it root, whatever you want to call it. We're going to distribute it through. This times this and this times this. So you multiply the numbers in front of the radical, which is 9. And keep in mind, anytime you take a square root of a number times the same thing, it's going to be the number under the radical. Because if you think it through, it's going to be the square root of 4, which would be 2. The square root of 2 times the square root of 2 is just 2. All right, same thing. There's a 1 in front of here, so it's going to be minus 3 root 8. Oops, root 16. So you multiply the 2 times 8, and you get 16. And so you're going to get 18 minus 3 times 4. Seriously, we just get a number? So 18 minus 12 is 6. So that is lesson 20, practice problem B. Okay, the next one is lesson 20, number 2. All right, this is a different kind of problem than we've just done. Lesson 20, number 2. Fewer than half of the performers were virtuosos. In fact, only 3/8 were in this category. If 28 were not virtuosos, how many performers were there? How many virtuosos were there? This book challenges my reading ability. Okay. So here we go. I always draw a picture of this. So, I mean, you don't have to. Let's see if it works if I draw a picture. I mean, a circle. You know, I'm a circle drawer. Okay, so fewer than half, 3/10 were in this category. Okay, so I'm going to divide it into less than it. So this would be 3/10, and then what's left would be 7/10 to make a whole. I know not everyone does it this way, but if you get stuck, sometimes this helps. That's a 3/10, even doesn't look like it. Okay, 28 were not virtuosos. Fewer than half the performers were virtuosos. This one were the virtuosos. Shoot, this is tough to pronounce. These were, and then these are the not ones, not virtuosos. Okay, how many performance, if 28 were not, so there's 28 in this group, how many performers total were there? Okay, the formula is always going to do like percent times total equals actual number, but this isn't percent, it's fractions. So 7/10 of the total is going to be 28. So I'm just going to flip and multiply. So 28 times 10 over 7, 28. Come on, 28. Then the 7 goes into the 28 4 times. So the total number of performers was 40 performers. Okay, let me just see if they ask for any other questions. How many virtuosos were there? Well, there were 3/10, so 3/10 times 40. So 10 goes into 43 times, and so we get 12 were the virtuosos. virtuosos. Okay, however you pronounce that. Okay. Or did they ask us for knots? Well, we can figure out both of them. How many, okay, it did ask us for how many. Okay, moving along. Number 20. Okay, oh, another figure. You guys like to do these geometry ones or have me doing them. Lesson 20, number 20. Okay, let me draw this real quick. So we have a line going across. We have a perpendicular line. Perpendicular lines form right angles. So we'll make a right angle right there. Oh boy, we have another line. Whoa, take that back. Let me get a nice line tool. Okay, we have another line coming down there somehow, and then we have another right angle coming straight up here. All right, and then we have letters all over the place. So this is a right angle. This is angle A degrees, B degrees, X degrees, C degrees, P degrees, Y degrees, and do we have everything? Okay, I think we have it all. Let's see what we have to do. It says in this figure, X is 140. Find A, then find B, then find C, then find P, then find Y. Okay, lots of things going on here. So they give us one piece of information and we should be able to find everything else. So let's give it a try. So X is equal to 140. So we have this one is 140. Because X is 140 and these lie on the same line, we know that A is going to be 40. Now, we know that this is 90, so we can find B. So we're going to take 180, because a triangle, the degrees add up to 180, minus 130, and we're going to get 50 degrees. B is 50 degrees. Now, C is also 50 degrees because these are called vertical angles, and vertical angles are congruent or equal, so it's going to be 50 degrees. We do the same thing to find P. So if this is 50 and 90 and this is 50 and 90, I don't even need to use my calculator. This is going to be 40. And then Y is a vertical angle, so it's going to be 40. Ta-da. Okay, 2 more and we're done. Number 28 is one of these ones where you have to be really careful because there's so many possibilities to make an error. And these tend to be on your test, at least one of them. Lesson 20. So negative 2 to the 0 power, and we have that looks like a brace, not a bracket. So let's do a brace, and we have negative 7 plus 3 minus the absolute value of negative 2 plus 9, absolute value of negative 2 times negative 2 to the 0 power. And I hope the person that asked me to do this is watching because I have a tip for them that I noticed on the tests that they took. Okay, so whoa, lots of issues to do here. Okay, first of all, this is 2 to the 0. The negative is not to the 0, so we're going to end up with a negative 1 outside of here. I have to let my dog out because it's driving me crazy, so I'll be right back. Okay, so once you do that, then we're going to start working inside out. So we're going to do inside of parentheses. So this is going to be negative 4, these two. Okay, I don't need the parentheses anymore because I did what's inside of it. Now, the absolute value, what you were doing on your test is you were making this one positive and this one positive, and you don't make them positive until you do what's inside of them. So I got a 7 here. If you would make this positive 2 and positive 9, you're going to get 11 and you're going to get the wrong answer. Now the absolute value of positive 7 is just positive 7. If this would have been a negative 7, you would have made it a positive 7. Absolute value is the distance that a number is from 0. So the negative still stands, we have a 7. So now we have this negative 2, and I'm going to do inside here. Same thing, this is this to the 0 power Doesn't include this negative sign, so it's going to be -1. So inside of here, we're going to get -1. This whole thing is -1 right here. And then it's going to be +5 because you have a negative and a negative make a positive. Okay, I'm going to do another step of combining. Let's see, I can do these two. So I'm going to get -11. And this in here, I'm just going to skip a step real quick, that's 4 right there, right? So we're going to get, it's going to be a +4, so it's going to be a -8. And we're going to get a -1 times a -19. And so the answer should be, I'm going to check it, should be 19. And it is 19. Okay. And the last problem is a similar problem. It is number 30. It's just this kind of arithmetic-ish math. So this is lesson 20, number 30. So we get 1 over -3 to the -3 power. I can't see so good at night anymore. -3 to the -3 power. Okay, the denominators are the same. That's very interesting. It looks like you could do this problem a couple different ways. You could probably just add the numerators together and then move it up, but I'm going to move it up right away. So, so you can't raise a number to a negative power, but we can move the whole thing to the top and make the exponent positive. This negative sign can either go on the bottom or the top. It doesn't matter. This whole fraction's negative. So I'm just going to make it all at the top, -3 to the +3. Now we have this positive negative thing, so it's going to be negative. When the signs are different, it's going to be negative. So we have a 3 up on the top, so it's going to be times -3 to the 3rd power, like that. Okay, now we're going to figure these out. -3 to the 3rd power would be -3 times -3 times -3, so it's going to be -27. Minus 3 times, again, -27. And I think that was is that a 3 up there? It's a 2. See, I told you I can't see at night. This is a 2, and this is a 2, and this is a 2. All right, so now we're going to get +27 plus 54. And your final answer is, oops, yeah. Let's see, it looks like I did something wrong. No, I didn't. Okay, let me just add those up. 27 plus 54, I hope I didn't do it wrong, is 81. Just double checking. I might have looked at a number wrong. Nope, I just got that 2 wrong. Oh, you know what? I can't see. This whole fraction is negative, and I didn't have that. In front of all of this is a negative sign. To me, it looked like one big long line. So this is -27 plus 54, and that's how we get a +27. Sometimes when they have these negative signs in front of it, it looks like the fraction bar is longer, but there's actually a space in there, I do believe. So it's 27. Okay, you might have missed that too. It's really easy to miss. Okay, guys, that's it for all the lessons. I hope someone finished this up. All right, we'll see you tomorrow.